Howdy, this is your friendly neighborhood physics teacher here, and I'm here to work on your metric practice problem set B. Now, a disclaimer, your practice problems are all scrambled when they're given to you, so I'm just going to do it in a pattern. You might have to jump around. My number one might not be your number one. So, let's start out with 65 kilograms. And we want to convert that into milligrams. Now, the first part, this problem, I will do it using the jumping method. So, jumping up the stairwell and moving the decimal. So, the only thing is I don't have a stairwell here. So, on your stairwell, you're going to start at kilograms, and you're going to jump until you get to milligrams. That should be 6 jumps going down your stairwell. To double check, you can use your exponents. So your exponent for kilo is 3. Your exponent for milli is -3. And you subtract those two numbers. You go from where you're starting, subtract from where you're going to. Now, a negative minus a negative gives you a positive. So that gets you 6. And if you use your stairwell, you will move it 6 times. Now, on your stairwell, since you're going down the stairwell, you're going to end up moving to the right. And that is positive. As you see here, the exponent is positive, so you'll be moving to the right. So 65. And if you don't have a decimal shown here, where does your decimal go? It goes right behind the number. Now you jump 6 times. 1, 2, 3, 4, 5, 6. And if you don't have any numbers in the places you jump, you put zeros. Very good. So now you have a 65 really big number. And that is converted. That is in milligrams. Okay, that is converted. That is an answer. That's in standard form. But we do not want the answered in standard form. We want the answered to be in scientific notation. To be in scientific notation, our decimal has to go right behind a non-zero number. A non-zero number. We need one number that's not 0 to be in front of the decimal. And so if our decimal is here, how many times do we have to jump the decimal to get to where we need it to be? We're going to jump it 1, 2, 3, 4, 5, 6, 7. We're going to jump 7 times. So now we have an answer of 6.5 times 10 to the 7. Still in milligrams. But how do you know if it's positive or negative? If you are going from a bigger number to a smaller number, it's going to be a positive number. So this number is bigger than that number. So therefore, it's a positive answer. And that is your answer in scientific notation. Take note that once I converted, I didn't mess with it anymore. That 7 just came from the scientific notation. Now, let's do the next problem. The next problem, we're doing 235 centiliters, and we want to convert that into kiloliters. So this I'm going to do purely the exponents. So the exponents that go with centi is -2. The exponent that goes with kilo is 3. You subtract. You subtract from where you're coming from to where you're going to. And that gets you a -5. Now, this is an exponent, that's an exponent, so therefore the -5 is an exponent. And you can do 235 times 10 to the -5. That is converted. That is in kiloliters. That is a standard form. But as scientists, we want it to be in scientific notation. And how you do that is we want the decimal to be behind one number that's not a 0. So that means we want our decimal to go there. But our decimal is there. So we need to move it 2 times. Now again, we're going from a bigger number to a smaller number, so it's going to be positive. This is an exponent. So we can go up here and add our exponents. So therefore, our answer is 2.35 times 10 to the -3 kiloliters. And that is our answer. So that's 2 different ways. Now we're getting into the word problems. So the first word problem I'm going to do is the bike one. So John, he rode his bike for 3 kilometers. Sally rode her bike for 5,000 meters. We want to know who went the furthest and by how much. And we want our answer to be in kilometers. So we need to convert our meters into kilometers. So again, let's look at our exponents. Meters is a base. Our base unit, our exponent, is 0. You subtract. Our exponent for kilo is 3. So 0 minus 3 gets you -3. Remember, this negative is telling you you're going to move the decimal to the left. So remember, if our decimal isn't presented, it's at the end of the number, and we're going to move it to the left 3 times. 1, 2, 3. So we have 5.0 kilometers. So John went 3 kilometers. Sally went 5 kilometers. Who went the farthest? Sally. But how much? How do you figure out how much more Sally went than John? You just subtract the numbers. So Sally went 5 kilometers. John went 3 kilometers. Subtract the 2. Kilometers. 5 minus 3 gives you 2 kilometers. And there you go. Now, if you want to put it into scientific notation, you want to make sure how many times did we have to move the decimal. Exactly, we didn't have to move it 0 times. So you get 2.00 times 10 to the 0 kilometers. And that's your answer in scientific notation. So our next practice problem is the peaches. So, some information the problem gives you. It says that one peach has a mass of 175 grams. Well, you can't just eat more than one peach. So we're going to buy 6. We're going to buy 6 peaches. Now, we need to make sure we have enough money to buy 6 peaches. Now, on the little card, buy the peaches, it says that it is $2.20 per kilogram. Now, we're in grams, the pricing's in kilograms. What do you think we need to do? Exactly. We need to convert. So, remember, grams is a base. So, grams exponent is 0. Kilo is 3. So, we're going to move it to the left 3 times. So, our decimal's here. So, we're going to go 1, 2, 3. So, we have 0.175 kilograms. One peach has a mass of 0.175 kilograms. But do we have one peach? Nope. We have 6 peaches. So we need to know how much mass 6 peaches has. So you're going to take your answer and you're going to multiply it by 6 because we have 6 of them. So if one mass is this, we need to know how much 6 mass. You plug that into your handy-dandy calculator. So you get 1.05 kilograms for 6 peaches. Now, that's how much 6 peaches have in mass. Now, the little card says we have that 1 kilogram is $2.20. We know we have more than 1 kilogram. So we know we're paying more than $2.20. So what you're going to end up doing is you're going to end up multiplying the two together because you're trying to compare. When you multiply those together, you get $2.31. Now, I have a sneak peek into the next little section. You can use dimensional analysis for this one because it's $2.20 per means divide. Per means divide. So per kilogram. And this, we have kilograms. We don't want our answer in kilograms. We want our answer in dollars. So we want kilograms to cancel out. So for kilograms to cancel out, it needs to go on top. So kilograms cancel out now. And this little line means multiply. So you multiply across, and you get 231. And that is your answer. The next problem we have is with Walt. We're trying to figure out how tall Walt was a year ago. So, it says that Walt grows 15 centimeters a year. He is now 1.2 meters tall. How tall he was a year ago, and we want our answer in kilometers. The first thing we need to do is convert. We're trying to go from centimeters to meters. We can't subtract those because they're not the same. So we need to convert our centimeters into meters. So centi is -2. Meter is 0. So we're going to move the decimal 2 to the left. Decimals here, 1, 2. So he grows 0.15 meters every year. And we want to know how tall he was a year ago. So if he's 1.2 meters tall now, a year ago, he should be 0.15 meters shorter. So we're going to subtract. So you get 1.05 meters. So that's how tall he was a year ago in meters. But the answer asks for it to be in kilometers, kilometers. So now, meters is 0 minus 3, because kilo is 3. That gets you a -3. The 0 is an exponent, the 3 is an exponent, so therefore the -3 is an exponent. And you can just do 1.05 times 10 to the -3 kilometers. And guess what? That's Orion's scientific notation. So that's your answer. So messing with your exponents keeps you from moving 3 to the right or left, realizing you have to move 3 to the right, and going back and forth that way. So there's the 5 problems. If you need anything else, please don't hesitate to come in for tutoring. If you need more one-on-one in the morning or after school, will be best for that. Hopefully you have a wonderful day. Bye.